We are going to continue where we left off on Friday with graphing sine and cosine curves. Okay, I've given you a handout that will be a part of our notes. Okay, you notice that both the sine and cosine curve are very similar, right? They both have an amplitude of 1. They both have a period of 2 pi. They have similar shapes. I think somebody mentioned on Friday they look just kind of like they're the same, but one is shifted from the other. Okay, and I would agree with that statement. But we got to be able to take any sort of transformations that happen and be able to graph our curve. Okay. Now, what I'm worried about one period of the graph. Okay. So what we highlighted in red up here for the sine and the cosine curve, that's what I'm going to be concerned about. Okay. So to make our lives easier, I'm going to teach you what's called the framing method, and that's why I gave you a handout so you don't have to write every single thing down. Okay. This is a framing method. So we are going to actually draw a rectangle. Okay, and I just want you to imagine if I draw a rectangle here, where that one period of sine curve is, it would be the same size as, and in the same place, as if I draw a rectangle enclosing the one period of the cosine curve. Okay, so that's why we're going to use the framing method. What we're going to do is we're going to find our starting point, and like I talked to Chris earlier today, our starting point is in reference to our frame. Okay, and it's going to be the edge of our frame. So what we're going to do, we're going to use the starting point, amplitude, and period to draw our rectangle. And then we are going to use some symmetry to figure out where our 5 points go. Okay, most of you have your notes open from Friday. We highlighted 5 points on each of these two curves. Okay. I'm going to come back to this, but we're going to use these dotted lines to help us figure out where those 5 points go. Okay, so this is what's going to happen, and I'll reference your blue sheet here. I'll come back to the bottom of your sheet. So just like we did on Friday, you need to figure out what the starting point is, the amplitude, and the period. Okay, I've included how you do that, just so it's all in one place for you to reference. Okay. When we talk about amplitude, we think of vertical spacing. When we think about when we talk about the period, we think of horizontal length. Okay. So we are going to construct a frame using these 3 things. So if we come back to this picture over here, we're going to plot the starting point. Amplitude is half the vertical height, and so we're going to have to go up the amplitude and down the amplitude, and then over the length of whatever that period is that we calculated. Okay, so that would be the size of our rectangle. Okay, now what we're going to do with that rectangle is we are going to split it in half this way so we can see kind of the middle of those wavelengths, and then we're going to split it in fourths vertically. Okay. On your blue sheet, I have indicated 2 different ways that you can do that. Okay, the method that I'm going to use is we'll have our starting point. We're going to add our period to figure out where we stop. We're going to cut in half, and then we're going to take those 2 halves and cut in half. Okay, and I'm going to go through with you how to do that. Now, if you try it and it's just not clicking with you, then you have a second option. You can take the period and divide it by 4, and you can add 1/4 of the period 4 times to get these 4 different marks. Okay, because we're going to need to know what X value we are at for each of those. Okay. Okay, so let's go to this part right here, and then I'll come back to the top. Okay. If we have our frame constructed, how do we draw in our sine and cosine curves? Okay, you are only going to put a coordinate at the intersection of either a dotted line or the outside of your frame. Okay, so we know that the sine curve looks like an X, right? So if we have a sine with a positive amplitude, we would want to start at the starting point. We go up, back to the middle, down, back to the middle. If we have a negative A value, what's going to be different about our sine curve? Okay, so we're going to start at the same place, but then we're going to go down first. Remember, if we're talking about one period, wherever you start, that is the height that you would need to end at, because then it needs to be able to repeat again. All right, our cosine curve, and this is what Chris was mentioning earlier. We have our starting point for our frame, but the cosine curve looks like a valley. So when we have our frame constructed, we're actually going to start at the top left corner of the frame and draw in our valley using those 5 points. And then if our cosine curve has a negative A value, where do we begin in relation to our frame? The bottom corner. Start on the bottom left, and we're going to make what looks more like a hill. So coming back to this portion of that blue sheet, okay? When you're up here looking at the amplitude, make sure you make a note to yourself whether there's going to be a reflection or not, okay? Because that is going to tell you which one of the pictures you need to make inside of your frame, okay? When you have the graph drawn, those 5 points I need you to label. Okay? I need to make sure that your spacing is correct when you draw these. Okay, I need those 5 points labeled. Now, when we construct the frame, we're going to figure out where each of those lines are essentially to make the frame. So labeling the points is going to be like the easiest part of this because we're already going to have everything labeled anyway. Okay. Okay, so just a quick review before we get into our 3 examples. You're going to plot your starting point. We're going to draw up and down the amplitude over the period. We're going to split that period into fourths so we can draw in our 5 coordinates and label them. Okay. The only thing that we're actually adding to this is making the frame. Okay, you know how to do the hard part of identifying everything. Now we need to actually just draw it in. I'm not actually going to give you graph paper to do it. I'm going to give you like a blank space. Okay, so go ahead and write down this first example. as you are writing, I do want to mention, if you ever grab your graphing calculator and you're wanting to just check to see if you have coordinates correct, make sure that when you graph any sort of trig function, it is in radian mode. If it is in degree mode, it is not going to be helpful for you. All right, so we need amplitude, period, and starting point. So Marissa, amplitude. Our amplitude is 1. Just make a note to ourselves that we will have a reflection of this curve. Okay. Our period. Maverick, how do we calculate it?
That's 2 pi over b.
Okay, and what is b in this case?
Pi over 2. No. X.
Okay,
So
so 1. Sounds good. So our period is 2 pi. All right. And then our starting point. Okay. Grace W, how do we get the x coordinate of our starting point? Okay. What's our C value? Okay. And what's our B value? Yeah. Okay, let's come back to this pi over 2. Are we shifting left or right? We're shifting left, so we want to make sure that we get that to be negative. All right, so our starting point is negative pi over 2, 3. Okay, that's the hard part. We're going for that. Now what we're going to do, very lightly, you're going to construct your frame. Okay, the frame isn't actually a part of the graph. It's just a rectangle to help you reference where everything should go. Okay, so you're going to draw it really lightly. So we have our starting point. We have a starting point of negative pi over 2, 3. We are going to go up and down the period. So if our starting point has a vertical height of 3 and our amplitude is 1, how far do we go up? 1. So we're at the y coordinate of 4 here. And what about down here? 2. Okay. So we use the amplitude to get that figured out. Now we're going to draw our rectangle, the length of the period. Okay. So if we begin at negative pi over 2, and our period is 2 pi, then what we would need to do is we need to take negative pi over 2 and we need to add 2 pi to figure out where we stop. If we take negative pi over 2 and we add 2 pi, where do we stop? 3 pi over 2. Oh. I'm just going to make a note in case somebody needs to look at that later. Okay, so we took our starting point and we added the period. Okay, so to construct our frame, very lightly make a dotted line horizontally to split it in half. Okay, and then vertically we're going to split this into quarters. Okay, so first of all, let's cut this in half. If we are at negative pi over 2 on the left and 3 pi over 2 on the right, what is halfway between negative pi over 2 and 3 pi over 2? Okay, let's talk very quickly about how to find the average, right? That's what we're finding, average. You're finding the middle. you're taking your very left plus your very right, and then you're dividing it by 2. So when we take negative pi over 2 and add it to 3 pi over 2, we get positive pi. Divide that in half. Divide that by 2, cut it in half. We have pi over 2. Okay. This next one is nice. What is halfway between negative pi over 2 and pi over 2? 0. And what is halfway between pi over 2 and 3 pi over 2? Okay, once again, if you don't see that automatically, add pi over 2 to 3 pi over 2. Okay, we would get 2 pi. Cut it in half, we get 1 pi. Okay. I do not care if you need to make these calculations over, like in your margin or whatever, but you do need to figure out where those are. Okay, those need to be labeled on your frame. Okay. Let me just real quick talk about that second method that I had on that blue sheet. Maybe you don't like doing that. Maybe you don't like cutting in half, cutting in half, cutting in half. Okay. Instead, if you wanted to take the period 2 pi and divide it by 4, because we're cutting this into fourths. Okay, 2 pi divided by 4 would be what? Pi over 2. So then we start at negative pi over 2. We add pi over 2 to get our next one. We add pi over 2 to get our next one. We add pi over 2 to get our next one until you have all of them labeled. Okay, that would be your other option. You would be adding instead of finding averages. Okay. Regardless of how you get there, you need your frame constructed and labeled. Now all we have to do is fit in the curve. Now we have a sine curve that has been reflected. So we're going to begin at the starting point, but since we have a reflection, we are going to go down first instead of up. And then since we have our frame labeled, we can figure out what those 5 coordinates are. Okay, the reason I don't have you do this on graph paper is I don't want you to get so caught up into labeling, like figuring out what your grids are on an XY axis, that you like make a teeny tiny graph that's this big, or you don't have enough room on the grid to make your graph. I just want to focus on where are we in relation to these coordinates, okay? Now, if you want to draw in the XY axis, just so you know where you are, okay, we know this is the Y axis because we have X is 0 here, and then the X axis would be all the way down there. Okay, so that's where your curve is. If you need that visualization, feel free to draw in your X and Y axis, but I'm not going to require it. Okay. Any questions about this graph before we try another one? Okay. What I'm going to have you do is I would like you to write this down and then as a pod work together on identifying the amplitude, period, and starting point. Okay, work together on amplitude, period, and starting point. Or find it and compare, however you choose. All right. Amplitude, pod 1. Period, pod 2. Starting point, the x-coordinate, pod 3. Negative 1/3, and the y-coordinate, pod 4. Okay, pods 1, 2, 3, and 4. The rest of the pods agree with it. Okay, questions on like the two or the negative 1/3? Those are really the two that are kind of strange. Okay. Do radians have to involve pi? No, they don't. So it looks a little awkward because we don't have anything with pi in it, but that's okay. Okay. So here we go. Our starting point is negative 1/3, negative 2. How far do we draw up from there? 2. So now where are we on the y-axis? We're at 0. Okay, and then we're going to draw down that same amount. So now we're at negative 4. Okay. We're going to draw over the length of the period. Okay. We begin at negative 1/3. Our period is 2. Where is it stopping? How many thirds? 5/3. We are taking negative 1/3. We're adding 2, so we're adding 6/3. So I'm going to do the cut in half, cut in half. You don't want to do that. Feel free to take the period, split it into fourths, and add that 4 times. Okay. Now I'm going to split it in half. We're beginning here at negative 1/3. We are ending at 5/3. I want to know what is in the middle. Two-thirds? Do you agree with that? Well, Chris agrees with himself. Okay, we take negative 1/3, we add it to 5/3, we get 4/3, right? And if we cut 4/3 in half, we get 2/3. Okay, I'm going to be very straightforward with you. You're working with a lot of fractions as you do this, no matter what. All right, now we need the middle. What is halfway between negative 1/3 and 2/3? Okay, if we take negative 1/3, we add it to 2/3, we get positive 1/3. We cut that in half. Talking about 1/6. 2/3 and 5/3. What is in between 2/3 and 5/3? 7/6. 2/3 plus 5/3 is 7/3. Cut that in half. We have 7/6. Cosine curve. There's a positive A value. We have a cosine. Where do we need to begin our curve? Okay, top corner. Okay, yes, I know our starting point is negative 1/3, negative 2, but remember that is the starting point for the frame of reference. Okay, and within our frame, we will start up at the top for our cosine curve. And then you can label those based on your grid here. So this is negative 1/3, 0, 1/6, negative 2, 2/3, negative 4, 7/6, negative 2, and 5/3, 0. If you don't feel like you have room on your curve to label those, it is okay to label them off to the side. Just make like a little list of the 5 points if you'd like. It's totally fine. Okay. Domain and range. We didn't talk about it in the first one. We're talking about it on this one. What is going to be the domain of any sine or cosine curve? All real numbers. Both curves extend on forever and ever and ever. Now we're only drawing a portion of it, but we know it keeps going in both directions. So you don't even have to think about it. All real numbers for sine and cosine all the time for domain. However, the range, this is where our frame is very helpful. Our range, what's our lowest point? Negative 4, what's our highest point? Okay, our frame stretches from negative 4 to 0 vertically. That's what our range is going to be. Okay, and I'll tell you right now, your quiz on Monday now, it's a nice Friday quiz, but now it's Monday quiz. Your quiz on Monday, your problem set Friday, I will ask you for domain and range of these cosine and sine curves. All right, let's do one more. Go ahead and write this one down. Identify amplitude, period, and starting point. Make sure you and your pod agree on those 3 things. Make sure you compare. Be silent. Okay, pod 5, what did you get for the amplitude? How about the period? Pod 6, your starting point. Rest of you, how do you feel about those 3 identifications? Do you agree? Any issues you have with them or questions you have with them? Okay, I see some of you already working away here. Okay, so our starting point is at pi over 4 is 0. We're going to go up until we stop where? We're going to go down until we stop -4. We're going to go over, how far? We're going to go over pi. So if we begin at pi over 4 and we go the length of pi, where are we stopping? 5 pi over 4. Okay. I'm going to do that second method just to demonstrate in case you would like to see it. If we cut our period into fourths, what would that be? We take pi and cut it into fourths. We would have pi over 4. So the alternative method for labeling this frame that is split up into fourths is we could just add pi over 4 until we get our, we'll just add pi over 4 times, right? So pi over 4 plus pi over 4, pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. 3 pi over 4 plus 5 plus pi over 4, 4 pi over 4, which is pi. Pi plus pi over 4 is 5 pi over 4. Okay, you could do it that way if you wanted, or you can cut in half, cut in half, cut in half. Okay, I'm not going to know which one you do. All right. It is a sine curve, so we begin at the starting point. Only sine begins at the starting point. Which way do we go first in this one? We go up first. Okay. Now, your book is going to tell you to graph 2 periods. Okay. If you graph 2 periods, I care less about the second period than I do the first. Your first period is going to be labeled, and it's going to look nice and pretty like this. Oh, I guess I did forget to label these here. Okay, so your first period, nice, pretty, labeled, okay? If you're going to draw a second period, then all I want you to do is draw your frame a second time. Mine's kind of squished in there, but bear with me here. And then just keep the pattern going, but you don't actually have to label the second period. Okay? It's more of just what would it look like if it kept on going. Okay, if you look on your gold sheet, let's talk about your gold sheet because everything got messed up. So on your gold sheet, get my pencil. Your homework tonight is 4.5b. Okay, So it's moved from Thursday to Tuesday. That stresses me out a little bit. Okay. You have 4 problems that are folded. 2 that are not folded. Okay. It is good. All right. So I expect each and every one of you to come in here tomorrow with at least 4 graphs attempted. Okay. What will happen then is tomorrow we're going to look at going the other way. We're going to look at if you have a graph, can you write the equation? And then Thursday we're going to look at graphing tangent as well as the reciprocal functions cosecant and secant. Okay. Friday now will be our activity with the problem set quiz on Monday. Not ideal, but there's really no flexibility at this point. I mean, we've had 3 days. We got to get things in. Spring break is a little different this year, and that 4-day weekend you have at the beginning of April is kind of at a weird time. It's earlier this year than last year, so we got to get things fit in when we can. We also have to get done with the seniors because they take the final with us before they graduate, and then the rest of us move on to more material. Okay. All right. Let me get this stopped.